In this video, I'd like to give an example of extracting data from a database, creating some variables, cleaning up the data, uploading it to RStudio, and running some regression. So the World Development Indicators is a really terrific database of cross-country information about economic and development indicators. Let's click on it. And you can see that it looks like we have this database interface where we have to make different choices, select countries, select series, and select time. And lots of databases are organized that way. So whereas, meaning we have to do some work to extract only a portion of the database because the entire database is very, very large. So in this case, let's do some cross-country regression. Let's say we're interested in trying to understand why some countries grow faster than others. I'm going to select actually all of the countries that this database has. So I'm going to select here under country. I'm going to check all the boxes. All right, and I got 217 countries. Fantastic. The next step is I have to select series. Well, look at this. There's a 1,443 different series. Clearly, I don't want them all. But if I'm interested in GDP per capita, so I want to know how developed the countries are and how GDP per capita changed. Let's see if I can put in GDP, if that actually comes up. So there's a whole bunch of indicators that are measured as percent of GDP. Oh, there's a GDP growth. Oh, GDP per capita, constant 2010 US dollars. That sounds like a reasonable indicator to grab because it's all going to be in dollars, so we can compare it across countries. It's in constant dollars, which means we're going to be able to compare it over time. So it's a real GDP per capita evaluated in 2010 dollars. So that's good. I got selected that series. What else do I want? Well, so I can certainly search by name, but if I click here, it also lets me search by topic. So we could see economic policy and debt and environment. Those of you interested in education and environment and financial sector, lots of different topics here. So I would like to actually investigate whether investment, whether building a capital stock has an impact on economic growth, in GDP per capita. So I'm going to look under national accounts, and how about let's select here shares of GDP and others. So here it tells us trade, gross savings. That's a good one. Oh, how about this one? Gross capital formation, right? From intro to economics, you know that GDP consists of private consumption, investment, government consumption, and investment, and net exports. So I want to know if the share of a GDP that's devoted to gross capital formation, that is investment, building factories, bridges, and equipment, whether that has an impact on subsequent economic growth. So I'm going to check that. I want that indicator. So now I have two indicators. Let's do at least one more. How about population? Because this has lots of countries. So let's see. I'm going to clear this. Population, hopefully it should give us a population. Okay, so there's access to electricity. Oh, maybe it's going to be right under P. Oh, there we go, population. I looked, you can see population, different ages. I actually just want the population total. Population, the largest city, dear. Population female, population living in slums. How about population total? So let's check that one. Fantastic. So we now have 3 series. you could see that we could keep going, but let's stop there. And now we want to select time. So we want these indicators from certain years, and we could grab all the years, but I'm going to take 2010, 2020, and I'm going to take 2010. It's also quite possible that not all of these indicators will be available for all of the years and all of the countries, but we selected 2 years, 3 series, 217 countries, apply changes, and we will see the data extracted. And we'll actually see that we're going to have to rearrange how the data is organized a little bit. It looks like it's giving us Afghanistan, and if I hear Angola, I can see those 3 indicators here. That's actually not how I would like them to be organized. I would like to have the countries in rows and the indicators and years in different columns. So this World Development Indicators allow us to change the layout. So I'd like country to be in row and the series to be in columns and the time also in columns. So I'm going to say apply changes, and oh, that looks good. That's how I would like the data to be organized, and that's true in general. When we work with data, we have variables in different columns and our observations in different rows. Here, in this case, the unit of observation is a country, because I have rows that consist of countries, 217 rows, 217 countries. So let's download this. Let's download it in a CSV file. Let's open it from the downloads folder. It's going to give some metadata. Let's skip that, but just let's open the data itself and let's see what it looks like. So this is exactly what we expected. Here we have 217 rows and a bunch of columns. Let's rename these columns so that it's easier to work with a little bit. So here we have GDP 2010. Here we have investment in 2010. Here we've got population in 2010. Here we have GDP, keeping in mind that it's GDP per capita in 2020. Here we have investment measured as percent of GDP in 2020, and here we have population in 2020. Fantastic. And we immediately see that there are some missing values. For example, we don't have investment in Afghanistan. Actually, it's quite I think we're lucky that we have the GDP per capita, only $549 in 2020. You could see it actually barely moved from 2010. Given what we know about Afghanistan, this is not this is sad, but not surprising. So I want to create a column here. I want to create another one using these columns as ingredients, because maybe I don't want just the data that the database gave me. Maybe I want to make some calculation out of these. And in particular, I said that I'm interested in understanding why some countries grow faster than others, right? So I'd like to know why Afghanistan GDP barely budged from 543 to 549. So I'm going to create this column called growth, and it's going to be a percentage change, really average annual percentage change in GDP. So that is at what rate would Afghanistan grow for these 11 years in order to get from 543 to 549. And we can do that by taking the 2010 GDP, dividing that by 2020 GDP dividing by 2010 GDP. If we raise that to 1/11th power, and then subtract 1, and the whole thing is multiplied by 100, then we get what is the average annual growth rate that this country experienced. So in this case, it's 0.1%. So let's copy that formula all the way down here. Oops, not that far down. We have 218, fantastic. So we see Albania grew at about 2% per year. Let's see, United States is going to be, yeah, about 1% per year is the growth in annual growth in GDP per capita, real GDP per capita. Let's actually delete these nodes here, because when we load it to R, we don't want that to be part of the data. We only want our 217 rows. But one of the things that we notice immediately is that for countries where we have GDP only in 1 year or neither of those years, we can calculate that. So there's an error. There's like a text here, and if you try to load it into R, it's not gonna like it, because it's gonna load that entire column as a text, as a character column, and we can't run regressions on the character column. So one of the things we could do before we load it up into RStudio is clean it all up, basically get rid of the countries for which we have incomplete data. For now, I'm going to leave it. I'm going to try to take care of it inside R. So let me save this. I'm going to save this as, I'll put it in my downloads folder, and let's call it, well, let's make it comma delimited. Let's call it growth and investment. Okay, perfect. I'm going to save it. Don't want to keep it in this format. Yes, I do. All right. So this is actually pretty nice data. I mean, you could see that you can work with this. You can run some regression. And so in the second half of this video, let's do that. Let's go to RStudio Cloud. I'm gonna log in. Sure, log in with Google using my Union account. And let's start a new project. I'm gonna call it, we'll leave it untitled, but you can call it your project. So I'm gonna wait a little bit. Fantastic. All right, first thing we'll click here so that we can type our code. Let's upload that data set that we just created, growth and investment. Fantastic. Okay, there it is. Now let's use our tidyverse library. Oh, there's no package, so we have to actually install tidyverse in a new project. So tidyverse here, install. That should not take very long. Perfect. Now that we have both tidyverse and Stargazer installed, we can load it into our session. And let's load the data. So I'm going to put the data in a data frame called D, and we'll use read_CSV, and the file is growth and investment.csv. Fantastic. Okay. And we have 217 observations and 9 variables. This looks all good. However, if you notice, if you click on this little triangle, you see that all of the variables except for population in 2010 are read as characters. They're read as characters because some of them have that value formula, some of them have 2 dots, and so R thought that these were character columns rather than numerical columns. So we're going to have to fix that a little bit. We can fix that using our mutate function. So we'll say mutate, and we'll change our GDP 2010 and make it as numeric. GDP 2010, and do the same thing with GDP 2020, we'll say as numeric. So we're changing really the data type from character to numeric. GDP 2020. Let's do investment 2010 as numeric, investment 2010, and let's also do growth. I think we call this variable. Oh, we just call it growth. Fine, we'll call it growth equals as numeric growth. So fantastic. So if I run this, it's telling me that there are some problems because some of those values are really characters and they can't be turned into a number. And so it replaced those values with NA, not applicable, which is fine. Because we don't have a number for all countries for all of the years. If we look at the data set now, we see, okay, where we had missing observations, now we have NAs. Before we had 2 dots, but 2 dots were characters. We want these columns to be numbers. Fantastic. So we can get our descriptive statistics, Stargazer, this as data frame D, and the type has to be text. Okay, very nice. We see that GDP, average GDP per capita in 2010 was about 15,000 with a minimum of 234, maximum 150. It's probably Luxembourg or Monaco or something like that. Growth on average, not 0.9%. But ranging from -6 to +6. So all these numbers look pretty reasonable. We would discuss them more. Let's estimate some regressions. How about first model? We'll just ask whether growth is related to the amount of investment in 2010 that a country did. So we're really testing the hypothesis that if a country in 2010 devoted more of its GDP towards building bridges and infrastructure and factories, did they experience faster growth? And let's do one more model where we're gonna control for the initial GDP. So we'll still have investment in 2010, but we're going to add GDP in 2010. So essentially asking whether, well, if a country start in the same position, that is, we control for their initial GDP, do countries that invest more, do they experience faster growth? Also, the coefficient on the initial GDP will tell us whether countries that start relatively rich, whether or not they grow faster or slower. That is, whether there is a convergence in GDP per capita, poorer countries catching up on rich countries, or whether there's a divergence, rich countries getting richer. So let's estimate these two models, we can use Stargazer to actually get a nice summary table of these two regression results. Again, the type is going to be text. And here are our regression results. Let's see what it looks like. Oh, perfect. We can see that actually investment has no effect on growth, no statistically significant effect on growth. The coefficient is positive, but not statistically significant. It's true even after we control for initial GDP per capita. But we do see that the higher the GDP per capita in 2010, the lower the subsequent economic growth, which is good news because that means that the poor countries grow faster. So that's one way you can do your empirical project in this class. And of course, there's a lot more that you can do, a lot more variables, a lot more writing, a lot more thinking, a lot more exploration of the data. But this gives you a skeleton of where we are headed and what I'm looking for.